Hey, welcome. Today we're going to deconstruct what could very well be the smartest phone of 2026, the Google Pixel 10 Pro. We're going deep under the hood to see how its take on on-device AI might totally change what we expect from these little computers we carry around everywhere. But let's kick things off with a problem I think we've all felt. You ever try out some cool new AI feature only to look down and see your battery just plummeting? Yeah. That trade-off, that battle between powerful smarts and all-day battery life has been the single biggest roadblock for truly useful, always-on AI. You know, that problem actually has a name. It's called the memory wall. And it's basically this bottleneck where the energy it takes to just move data from your phone's memory to its brain, the processor, is actually more than the energy it takes to do the fancy AI calculation in the first place. This data traffic jam? Well, that's the main villain of our story today. So, how did Google go about smashing through that wall? Here's our roadmap for this explainer. We'll start with that core AI problem, then we'll look at Google's new blueprint, dive inside the Tensor G5 chip, uncover the absolute breakthrough that is TurboQuant, see how the hardware and software talk to each other, and finally, explore the payoff, how your phone becomes a proactive agent. Okay, first step, the smartphone's AI problem. Let's really get into the nitty-gritty of the challenge that's been holding back on-device AI for so long. So here's the deal. To run a really sophisticated AI model right there on your phone, you have to shuffle enormous amounts of data back and forth between the system RAM and the processor. It's this constant movement that generates all that heat and just drinks power. It's not the thinking that's so expensive, it's the shipping and handling. Which brings us right to Google's solution. Let's move on to their AI-centric blueprint, a completely new vision that meant they had to rethink the smartphone from the ground up, starting with the silicon itself. And this quote, man, it just nails their whole ambition. This isn't just about making a phone that's a little bit faster. The goal here is to shift the smartphone from a reactive tool that just sits there waiting for you to tell it what to do to a proactive, context-aware agent that actually anticipates what you need next. Now, a vision that big needs some serious muscle to back it up. So let's explore the first pillar of this whole thing, the custom silicon at the very heart of the Tensor G5 chip. Okay, this is a huge deal. It's Google's first fully custom-designed chip, built on TSMC's cutting-edge 3nm process. It's paired with a whopping 16 gigs of super-fast RAM, and this is key. It's designed for sustained AI performance, not just getting a high score on some benchmark test. And at its core is a new tensor processing unit, the TPU, that's 60% more powerful than the last one. And right here, we can see what that actually looks like in practice. The Geekbench scores show a really clear jump from the Tensor G4 to the G5. That new custom architecture is delivering a serious boost in what the phone can handle, both for single tasks and when it's juggling a bunch of things at once. But look, hardware alone can't solve that memory wall problem. The real revolution here, the secret sauce, is an algorithm. Let's get to the most crucial part of this whole explainer, Pillar 2. The key is this groundbreaking compression algorithm called TurboQuant. And this is the piece of the puzzle that doesn't just chip away at the memory wall, it pretty much demolishes it. So how on earth does it work? Well, it's this incredibly clever two-stage process. Think of it like trying to pack a suitcase as efficiently as possible. The first step, polar quant, doesn't just cram the data in there, it converts it into polar coordinates, which is kind of like neatly folding and rolling everything to get rid of all the wasted space, the metadata overhead. Then, the second step, QJL, is like a final quality check. It uses this tiny 1-bit transform to fix any little errors, making sure the compressed data is basically identical to the original. So what does all this clever packing actually get you? First up, a massive 6x reduction in the AI model's memory footprint. So that suitcase we were just packing, it's now 6x smaller. And because that data is so much smaller, you can move it around way faster. This leads to up to an 8x increase in the speed of what's called attention throughput. That's the core calculation AI uses to understand what you're asking it to do. But here's the absolute magic trick, the kicker. For all of that incredible compression and all that speed, you get virtually zero loss in model accuracy. You give up nothing in exchange for these massive gains. That is the breakthrough. Okay, so you have this custom chip and a revolutionary algorithm, but how does the phone's operating system actually use them? Well, let's move to Pillar 3, the software bridge that connects it all. And that job falls to something called LiteRT. You can think of it as the next generation of TensorFlow Lite, and its main role is to act as a universal translator. It's the essential software layer that lets Android 16 and all your other apps talk to the Tensor chip and TurboQuant and access all that power without a hitch. All right, we've walked through all three pillars, the chip, the algorithm, and the software. So what does all this tech actually add up to? Let's talk about the payoff and what this really means for you when you're actually using the phone. One of the best examples is a new feature called Magic Queue. It basically tries to anticipate what you need before you do. So let's say a friend texts you asking where you're meeting for dinner. Magic Queue can automatically see that, pull the address from your calendar event, and let you share it with just one tap without you ever having to leave your messaging app. And then there's Gemini Live 2.0. This is wild. It's a built-in assistant that can use your camera to understand the world in real time. You could literally point it at your car's engine and ask for repair help, or to screen of code to get debugging advice. It's like having an expert for almost anything right there on your device. And this is the point that ties it all together. These incredible, almost futuristic features are powered by the Gemini Nano AI model running entirely and privately on your phone. It's only possible because that whole system, the Tensor chip, the TurboQuant algorithm, and the LiteRT software are all working together in perfect sync. Now, to really put this into perspective, just look at the memory requirements of today's top AIs that live in the cloud. They're measured by their context window, which is like their short-term memory. A bigger window means they can remember more of a conversation. Gemini 3.1 Pro can handle 2 million pieces of words, or tokens. Claude Opus, 200,000. These models are gargantuan. Trying to run anything even remotely this powerful on a phone would have been a total non-starter without a crazy compression technology like TurboQuant. And that leaves us with one last big thought. As this on-device AI gets powerful enough to actually anticipate our needs, to handle more of our daily mental heavy lifting, and to do it all instantly and privately, is your phone really just a tool anymore, or is it becoming something else? Something more like a co-pilot that helps you navigate your day? It's definitely something to think about.